let's begin. So we're looking at displacement. Displacement on a VT graph is determined by calculating the area between the graph and the time coordinate, and I'm just going to replace that with the word axis, over the time interval in question. It's the area. If you're taking calculus, they're going to say the area under the curve. Okay? What I mean by that is the area between the graph and the x-axis. The problem is that in calculus it's always above, or almost always. But in physics, because we deal with vectors, sometimes it's below. I'll deal with the below part in a bit. But technically, it's the area between the graph and the axis. So right there, there's the axis, there's the graph. What is that area? What shape is it? It's a triangle. Is it shaded in on your picture?
Yes,
it is. Okay, so we're talking about the area. In the example, the displacement for the time interval in question, so I'm just going to say let's do interval A, which is from 0 to 2 seconds, would be equal to the area of the triangle formed by the graph and the time axis. And we know that to be a triangle. Formula for area of a triangle? Base times height divided by 2. Or some people prefer 1/2 times the base times the height. Same thing, right? Divide by 2 times by half, same thing, right? So I have it written over here. I have half the base times the height. So let's have a closer look at this triangle. What is the value of the base? Well, the base goes from 0 all the way to 2. So how long is the base of my triangle? 2, right? From there to there is 2. And what is the height of my triangle? Now it's 2 squares, but you'll notice that it goes up by 2's, right? So the height of the triangle is actually 4. So I've got 1/2 the base times the height, 1/2 of 2 times 4, times 4 is 8, times a half is 4 meters. So we would say that the displacement from 0 to 2 seconds is 4 meters. Now, someone spotted this morning, so I'm going to point it out to you guys as well, how the units work. If you multiply these, look at here I've got seconds, and here I have meters per second, right? So I've got seconds times meters per second, and what happens? The seconds cancel out, and you're left with meters, which is why it's the displacement. Okay, so it's the area between, maybe just leave it flat like that. That won't, is that okay? Okay. All right, so we're talking about the area, and that is equal to the displacement. Now, if you are taking calculus, they will call this integration, or taking the integral. Something for you in university. You'll be sitting there one day, intro calculus, and they'll start integration, and you go, oh yeah, I remember Mr. Bennett doing that. That was the day we watched that really cool video on Plato where he thought the woman's womb was an animal and it went to their body. You'll think that in about 3 years from now. No one's agreeing. Jayden half asleep. Okay, so we found the area to be 4 meters. Now, what do we do if there's more than one interval? Like, let's say that I wanted to know how far it goes from 0 to 5 seconds. Well, let's do it in red so you can see better. There's 5 seconds, right? So what am I going to do now? What shape is that? The rectangle. How do I do the total displacement? Do the triangle, do the rectangle, add them together. It's not rocket science. If more than one time interval is to be used in the calculation of displacement, then the total displacement is the sum of the displacements for each time interval. In other words, find the individual ones and add them together. If the displacement for intervals A and B to be calculated, the following technique would be used. So the area of A we already know to be 4. So what's the area of the rectangle? What's the formula for area of a rectangle? Say again, sorry. Base times height, says Connor. He's right. Or length times width, right? Same idea. Base times height. So what is the base? Well, it's from 2 to 5, which is a base of 3, and the height goes up to 4, and 3 times 4 is 12. Which means my total displacement, my total area of red is 16 meters. Put your hand up. Scale of 1 to 5, how much you get? 5 being totally get it. Give me the text. I can't see your hand now.
Oh, okay.
5 is totally get it. 0 is I don't know what you're talking about. Speaking Spanish. Yeah, there's an in between. 0, 1, 2, 3, 4, 5.
3.
Do the last of the end. How do we find the area of the total red? We take the area of the triangle. The area of the other area of the rectangle. Okay, so it's like from 2 to 5 is a distance of 3, and we're going up 4. 3 times 4 is 12. What you do to find the area of that shape. Oh, yeah. No, it's a 12. Fair enough. 12. Okay. Now, what do you think you do when the graph is below the axis? Below the axis means the velocity is?
Negative.
Which is to the? So, which way is the displacement? Which is? Negative. So if the graph is below the time coordinate, then the displacement is negative. The displacement for the time interval d would be calculated, shown below. So here's what you do. Here's the one little sort of wrinkle, is that it's not below the graph. Kids get lulled into the sense of it's below, but in real, and they do this. This is the mistake. Do not do this. I always wonder if I should say don't do this, because what happens when you say to a kid, don't touch that? They want to touch it. Right? So should I show you what not to do? Okay, if you're one of those persons that's going to touch it, when someone says don't touch it, close your eyes. Don't do this. They do this. They say like below, so time interval D, this is A, B, C, this is D here, right? So they do this here. What's wrong with that? It's not below, okay? It's not below when the graph is, well, below, negative, right? What should you do? You should go between the graph, and if you have to do this, between the graph and the axis, and then you just have to complete the rest of the shape. So in fact, when the graph is below, it's actually the area that's above, and when the graph is above, it's actually the area that's below. Kind of like the opposite. Go to the axis, exactly, okay. That's a good way of putting it. Okay, so now let's have a look at this triangle. So this triangle, what's the base? It's from 7 to, it looks like, 8.5. So that's a base of 1.5. And then the height is negative, so it actually goes down to -3, right? So 1.5 times -3, which is minus 4.5, right? 1.5 is my base. 1.5 is my base, from 7 to 8.5. We didn't add them, I multiplied. Well, I mean, I guess I did add them, but they're not, that's just coincidence. Right, multiply, 1.5 is the base, the height is -3. 1.5 times 3 is minus 4.5. How come I got an answer? Because I what? I didn't divide by 2. Why do I have to divide by 2? Because it's a triangle. I made that on purpose. This morning I didn't make that mistake on purpose, and I spotted it, and then everyone figured it out. So I thought, well, I'll see if I'll make that on purpose this afternoon and see if you spot it, and you did, so that's good. Is that a common mistake that people will make? Yes. What are the only shapes you're going to have to deal with? Triangles and rectangles. Any circles? That would be a curved shape, and then you'd really need to be taking calculus. Basically just triangles and rectangles. Okay, so make sure you multiply by 1/2 on the triangles. So, what's the area for A? 4. What's the area for B? 12. And the area for C is? Minus 2.25. Some people like to just like fill in those values right there, if you want. I guess it's there, right? Okay. So I've shown you how to do it. I hope you've been listening, because I want you to do intervals C, E, and F. Okay? Well, look up here to see where those intervals are. So interval C is from 5 to 7, You might want to write that down on your page. I don't know, or is it there? It's there? Okay, so C is from 5 to 7. E is from 8.5 to 11. And F is from 11 to 14. C is from 5 to 7. E is from 8.5 to 11. Did I just say 5 to... And F is from 11 to 14. Okay, you guys take a minute and do those. I'm going to do a 10. Feeling good? Correct answer for number 1 is 4. 4.
Look at that. This has been a resource time getting.
Yeah? All right. Let's see here. If you didn't get it, here's how to do it. Have a look here. So, it's a triangle, right? It's from 5 to 7, so that's a base of 2. The height is from 0 to 4, but it's a triangle, so we divide by 2, so my total is 4. So if you didn't get it right, write down beside interval C that it's 4, because you're going to need it in a bit. Write the correct answer down. Watch, Kaylee. Watch, okay? Excellent. Interval E is the flat one, so it is a rectangle. From 8.5 to 11 is a total distance of 2.5. The height goes down to -3. So 2.5 times -3 is -7.5. How'd we do? Oh, we got lots of different answers there. Why did we get so many different answers?
I thought it was 3.5.
I think it's 3.5 parts.
Got all sorts of different answers. Yes, it's the easy mistake to make. I did this on purpose. I put these going up by 2s to remind you you can't just count, right? You got to look and you got to think. Don't be in such a rush. It's 2.5 times -3. -3. Interval F is this one here. It is a triangle. Okay, the base is from 11 to 14. That is a distance of 3. Okay, and just have a look. The height is -3, so 3 times -3, but it's a triangle, so divide by 2, -4.5. Lots of different answers, apparently. Lots of different answers, I see. Why is it what? Because the height down here is -3, right? The height of the triangle is how far it goes away from the axis.
So like here we count.
Okay. Here's the second thing to learn today. How do we do average velocity? Okay. Pencils down, ears open, don't even look at the screen, just look at me. If you have a 50 on one test and 100 on the next test, what's your average? 75. What if you got 50, 100, 100? Still 75? What if you got 50, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, and 100, and 100? Exactly. Okay? Don't make this mistake. Don't just take the first number and the last number and add them together and divide by 2. It doesn't work. Okay? If one has more of, then that's count for more, don't you think? Like if you've got more hundreds, it counts for more weight. Okay, that's what I'm getting at here. Okay. So, whenever the average velocity is to be calculated under any circumstance, it must be done using the formula V equals d over t, where the displacement, how do we get the displacement? By finding the area. You have to find the displacement first using the area. Let me give you an example of what not to do. If you're one of those people that has to touch it because it's hot and you were told not to, don't listen. Okay. Find the displacement using the area. Here's what people want to do. If I say find the average velocity for intervals A and B, which is those two right there. I went a little too far. Here's what they want to do. They want to say, well, it starts at 0, and it ends at 4, and so the average is 2. That is 100% wrong. Wrong, wrong, wrong. You just went, I got a 50, and I got 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, 100, and my average is 75. That's what you just did. More hundreds count for more. How long is it at 0 for? Just at the very first instant. And then it became 2, and then 3, and then 3.75, and then it went 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. So what's the average going to be close to? 4. If you had to estimate, what would you think it would be? 3.75, says Lawson. Let's just see. How do we find it? We're going to find the displacement, and then we're going to divide by the time. Now, we already know what the displacement for interval A is. It was 4, was it not? And what was the displacement for interval B? I think it was 12. It's shown right here. Right? A is 4, B is 12, which is a total of 16. Now I'm going to go D over T, and I'm going to take that 16, and I'm going to divide by 5. Why 5? Because I'm going intervals A and B, and it goes all the way to 0 to 5. Total time. 16 divided by 5 is 3.2, a little less than Lawson's estimate. What were the steps to find average velocity? Find the area, and then divide by the time. And so now I ask you this. Determine the average velocity for the entire trip to one decimal place. How do we find the average velocity for the entire trip? You got to find the total displacement. Conveniently, we've already figured out all 6 individual ones, so what are you going to do? Add them up and divide by the time. Giver. It is a clicker question where it says determine the average velocity for the entire trip. You're going to find the total distance. Yeah, you just have it right here on that's all. I know. All you got to do you have all of the individual displacements? Yes, we just went through it. We did. A was how much? 4. B was 12. We figured out C. I gave you the answer. It was 4. D was given. It was negative. D was minus 2.25. E is minus 7.5. And interval F is 4.5. So you're going to add them all up. Does the negatives matter? Oh yeah, the negatives matter. Huge. Correct answer is 0.4. And yay, the majority of you got it right. I got one person at 0.41. And I got a whole whack at 1 decimal place. I'm telling you, you guys have to pay attention to that sort of stuff. They will, multiple choice questions in the university will. Someone forgot to divide by the time.
Whoa, that'd be me.
Okay, so again, I hope you know what you did wrong. What's the total displacement, the number? What's the total displacement? Who has the number?
5.75.
5.75? It's the total displacement, and we're going to divide by 14 seconds, and it's 0.4, right?
Yeah.
Okay. Now, we did these yesterday, but we might as well do them now because we got the clickers up. So, instantaneous velocity, how do we find it? From a VT graph, Adam, more learning here. Instantaneous velocity on a VT graph. Travis, how we're going to do it? We're going to read it directly off the graph. So go ahead and tell me what V inst is at 13 seconds. Right there. Yep, going to right now. V inst at 13 seconds. Think a little bit about what you're doing before you enter it in. We're looking for instantaneous velocity. Instantaneous velocity. We're getting two possible values. D, get the music out of your ears. Well, actually, I think that one there is not answered yet. That's what the one on the left is. This is not answered. 10 people still to answer. V inst, you're reading it directly off the graph. I'm now down to 4 people. Down to 2 people. Once again, you're reading it right off the graph. And so the answer is, well, we know it's not 100%, right? Correct answer is -1. Why is it -1? You're reading it right off the graph. Last one. Stay with me, you guys. Last one. Instantaneous acceleration. We are looking for slope from a velocity time graph. We're looking for slope. It's determined the same way off VT graph is. That is to find the slope. You may need to draw a tangent line if the graph is curved. So I want to know what the instantaneous acceleration is at 12 seconds. How do we find it? At 12 seconds. How do we find it? Go. Instantaneous acceleration at 12 seconds, right there. Instantaneous acceleration. Correct answer is +1. Someone entered, yeah, 1. Okay, I'm not sure what's going on there. Well, I know that it's not -1. How do I know? Because the slope is positive, going up. The slope. Y value here is 0. The y value here is -3. It's 0 minus -3. Your time is from 14 to 11. Rise over run. You use it. Yes, Travis, you're right. Travis says, I thought that was for average, but because it's a straight line, the slope here is the same as the slope there, is the same as the slope there, and there, and there, and there. It's all the same. All the same. Okay. These next 2 pages are the most 2 important pages you've had up to now. Okay? Do not lose these 2 pages. I would suggest you open them flat, side by side.
Are we learning it now?
Okay, I'm going to do the summary. Pay close attention. Get them open side by side. Next 2 pages, the ones that say summary. There we go. Okay. Down the left-hand side, you will notice, think way back, we talked about position time graphs. So, if you have a position time graph and you are asked to find displacement, d or sometimes delta x is final minus initial, you just read it off the graph and subtract. If you were asked to find average velocity and it's a straight line, what do? You find the slope, and you might want to draw these little pictures on the side to help you. Great, are you following along? Yeah, so why don't you do that, please? If you have a position time graph and you are asked to find average velocity and it's a curved line, what do? Do not draw the tangent. We're asked to find average. So you actually connect the two endpoints of the curve. That is not a tangent line. Tangent line is when it touches the curve, not joins the endpoint. Right? So average velocity, you're finding the slope. Instantaneous velocity, like we just did, if it's a straight line, you simply find the slope. And if it's a curved line, that's when you draw a tangent. Those are all the rules for position time graphs. How important is it that you look to see what kind of graph it is? Pretty darn important. It's like getting north and south backwards. Because if you start going north and you think you're going south, right? Because if you think it's this kind and you do all of these, well, guess what? Every single question will be wrong. You can, but a cheat sheet's not going to help you with what kind of graph is this one that I'm looking at. Absolutely. You can put all of this on your cheat sheet. But it still doesn't save you from using the wrong chart, right? If you pick the wrong chart, there's a creek that you'll be up. Most people know the name of it without saying it, right? Just so you know. I think it's on CBC. Yeah, it's a comedy. I think it's called Shit. Okay, if you have a velocity time graph, Calvin, here's the rules. If you have a velocity time graph and you're asked to find displacement, what do? You find the area. Remember that above is positive, below is negative. If you have a velocity time graph and you're asked to find average velocity, you use the formula V equals d over t. And how do you find d? Area. So it's really area over time, right? If you have a velocity time graph and you're asked to find instantaneous velocity, well, that's the easiest one. You simply read it off the graph. It's a graph of velocity. If you now, did you notice that the second page, the columns were the same? Yeah. Did you notice that? If you have a velocity time graph and you're asked to find average acceleration, what do? Well, if it's a straight line graph, you simply find the slope. What if it's a curved line graph? You draw a line between the 2 points of interest, in other words, the endpoints, and find the slope. Slope is always rise over run, y2 minus y1 all over x2 minus x1. We've done a lot of slope. You should be experts at slope. People might say it's a steep learning curve. I say no. I say it's a flat learning curve. Instantaneous acceleration on a velocity time graph, you would, straight line. If it's a straight line, instantaneous means at a single point. So what do? Find the slope. What if it's instantaneous acceleration and it's a curved line? Draw a tangent.
Wait, is that 3 dots?
Yeah, because instantaneous. So like if you're looking at that point there, you can pick any dots and pick your slope, right? When you're finding slope, you can pick any 2 dots you want.
In the tangent line, too, any two.
That's correct. On a tangent line. Any line. Any line. Are those 2 pages valuable to you?
Very valuable.
Oh yes, they are. Don't lose them. Okay, give me 30 more seconds. Yesterday, I suggested you just do graphs, on graph 1, you were going to do like A to F. Now you can do all of graph 1, all of graph 2, all of graph 3, all of graph 4. Should you do them all? Probably. Probably. You have a link with answers. You have answers. You have a link to solutions. You have a QR code to solutions. When you're done all this, there's a hand in to see if you know what you're doing. You're not getting it until at least 3 of those are done. You got time to start right now. 3 graphs.